Jasmine Lim, and the company that I was working for is called Simrise. So Simrise is a flavor and fragrance manufacturer as well as a cosmetic active ingredient supplier. They have two major segments. They have the flavor and nutrition segment, and then they have the scent and care segment. Obviously, as a cosmetic science student, I was working in the scent and care segment. So Simrise is a global company. They have many sites around the world, as you can see in yellow, and I was working here in the regional headquarters for the Asia Pacific region in Singapore. So my role in the company, I was working in quality control as a lab administrative assistant, working with fragrance raw materials. My role was mainly lab-based, so I was doing analytical chemical tests such as acid value and gas chromatography, as well as preparing chemical standards that I required for my tests, such as titrants and solvents, as well as doing sensory evaluation for what I needed to test for my raw materials for differences. So my project was based on acid value. And acid value is the amount of potassium hydroxide in milligrams you need to require to neutralize the amount of free fatty acids in 1 gram of a material. This is a neutralization reaction which forms a salt and water. Usually to test an acid value, you would use a method called titration. So titration, the end point for a titration is to find your equivalence point, which will give you an acid value. And equivalence point, chemically speaking, is when the amount of acid is equal to the amount of base in terms of stoichiometry. Normally you would find this type of titration in a lab, which is a manual titration with a manual burette and a conical flask with a color indicator. But the one I was working with is an auto titration, which is found in the industry, with a manual loading, auto-loading burette and a sensor. Normally for a manual titration, you would look for a change in color shown by the indicator, but for my auto titrator, you would look for a change in voltage over milliliters, which is detected by the sensor. So this is the titration curve that usually comes out of the auto titrator. The equivalence point would most likely be found somewhere between these 2 points as I marked on the screen here. So when a material comes in, we will test it for acid value if necessary. We would normally expect the trend to be that it would increase over time because of maybe oxidation or hydrolysis. However, if we find that there is a high acid value for our material, we may have to reject it because it is an indication of spoilage, which would affect our final product. So when a material comes in, it comes with a certificate of analysis. This is also called a COA. It comes with details from the supplier of the test that it has carried out before sending the materials to us, which includes acid value. So because we were a quality control department, we needed to test, make sure that our tests were accurate and reliable. And so we decided to take this COA data and compare it to our in-house measured data. And what we found was 72% were showing a decreasing difference in value over time, which is going against the normal trend, which is meant to increase. So for example, the COA was showing 1 and our machine was detecting something like 0.75. So obviously we need to change something. So I created the aim to improve the accuracy and the reliability of this method and test. I created 4 objectives, which is make and use a chemical standard, identify the potential issues, use the comparison of the results as primary validation, and use actual sample results again as secondary validation for the new method. So looking at the first objective here, I used the chemical standard of palmitic acid. Now palmitic acid is a long-chain fatty acid of 16 carbons. The reason why I chose this material for my chemical standard was because of its similarity to some of the materials that I would get in my lab. So I made up 2 standards, one of 2.5 milligrams of KOH per gram, one of 5.0 milligrams KOH per gram. For the purpose of this presentation, I would call this one the low and the high standard. So I did 3 experiments for each of the standards in the machine, and this is kind of the results that came out. So the values were not comparable to our theoretical values, and the titration curve, as you can see, is not really comparable to the expected titration curve. This was the same for both the low and the high standard. So we looked at a factor that we could change. So the first factor we looked at is called threshold. So threshold is the minimum change in voltage over ml required to identify our endpoint. So before it was 30, so after 30 millivolts per ml was exceeded, then it would detect that as the equivalence point. We decided to increase this to 50 MV per ml because it will give it a bit more chance to detect the correct endpoint. However, when we ran this through the system, as you can see, the graph is still not very comparable, and the values and the theoretical value was not matching, and the percentage error was also unacceptable for both the low and the high standard. So we looked at a further factor, which is the number of equivalence point factor, which is the minimum number of equivalence points need to be detected before the titration is completed. So after the machine detects one equivalence point, the reaction would stop because it doesn't need to waste any more of the titrant. We increased this to 2 just to be able to skip that first equivalence point, which was giving an incorrect result. So looking at the low standard, as you can see, the titration curve is now matching to expected, and the values were falling within the acceptable range, and the percentage error reduced to 10.3, which is within our acceptable range. However, for the high standard, 2 of the tests turned out okay, but one of the tests, as you can see, there is a missing equivalence point detected here, and this showed in our average percentage error, and it brought up the average. So we needed to look at a further factor so that this could be rectified, because we get high acid value chemicals in our lab. So we looked at a factor called termination. So this is the minimum amount of titrant that needs to be used before the titration is completed if an equivalence point isn't detected. So if the first equivalent point is detected and the second one isn't, it will continue going until 10 ml of the titrant has been used. So we decided to increase this to 20 because it gives the machine more chance to detect the correct equivalence point before terminating the reaction. So looking just at the high standard here, you can see that there is a definite second equivalence point being detected. The values for the 3 tests fell within the theoretical value range, and the average percentage error reduced to 6.5, which is great. So looking at the COA data compared to our in-house data before and after the method change, as you can see, before there was a decrease of 72%, and after there is a decrease of 38%, which is a significant change as the majority is now increasing, which is going with our trend. So because of my primary validation and my secondary validation, I can now conclude that my method and accuracy and reliability of my method has been improved. So this was my placement project. So moving on to what I learned from the year, starting with my professional development. Obviously, working in the lab, I would develop a lot of my lab skills. I developed some sensory skills, working with fragrance raw materials, improving my time management skills, needing to know what tests can be done in the time scale that I had, and also working in a team. I developed a lot of team building skills, attending various team building events, building sandcastles and making domino mazes. So moving on to my personal development, obviously moving to Singapore is a huge change for me. I had to develop a lot of more communication skills, social skills, how to make new friends while I was over there, as well as adapting to the cultural differences between here and there. I also developed a new interest while I was there, something called vlogging. So every week I would post one video on my YouTube channel. There's a shameless plug. And so every week I would post a video just so that my friends in the UK and my family in the UK could kind of keep up with what I'm doing whilst I was there. This is something that I found I really enjoyed and something that I'm actually continuing to do even after my placement year. So I'd like to take this opportunity to thank my supervisor, Soon, and my head supervisor, Dr. Rakesh, as well as my 2 raw materials teammates, Jun Chen and Amita Cyril, for their help during my placement project and throughout the entire year. And thank you for listening.